Yes, so today's topic for us is valence electron and valency. So what are valence electron and where are these valence electrons? So if we see the structure of an atom, how it is? So this is the nucleus, this is K, this is K shell, this is K and L, and as we go further, the shells come close to each other. Okay, the distance between the shells come close. So K and M, and this is N. So N is more close to M. Okay, so K, L, M, and you can go further alphabetically according to the number of electrons. So the number of the electrons which are present in the outermost shell of an atom. So the number of the electrons which are present in the outermost shell of an atom, those electrons are known as valence electrons. And these valence electrons are found in the outermost shell. The outermost shell of an atom consists of electrons. Those electrons are known as valence electrons. So you can define the electrons present in the outermost shell of an atom, or the element are known as valence electron. If I talk about hydrogen, so what is the atomic number of hydrogen? Hydrogen's atomic number is 1, means hydrogen contains 1 electron. Okay, only 1 electron. So 1 electron will come in K shell. So K shell will be the outermost shell, you can say, and the outermost electron will be in K shell. So the valence electron is present in the K shell. Okay, for hydrogen. If we talk about helium, so helium having 2 electrons, having 2 atomic number and having 2 electrons, number of protons is equals to number of electrons. So helium is having 2 atomic number, so 2 protons, 2 electrons. So 2 electrons comes in K. So K will be the outermost shell, and the valence electrons will be 2. So the electrons for helium will be 2. Basically, we will not say that the valency of helium is 2, because it is containing 2 electrons in K, and the K consists only 2 electrons. K का जो हम बोलते हैं distribution of electrons के बात करें. So if we talk about distribution of electrons, so K consists only 2 electrons. So if somebody has an atom have 2 electrons, so that shell is full. So for K, for helium, it is containing 2 electrons in the outermost shell, means in the K shell, and 2 is equals to the complete shell. Okay, so the K shell contains only 2, can accommodate only 2 electrons. So the octet, or that is why we say helium as duplet. Helium contains 2 electrons, and that is the outermost shell, and it is stable, it is a noble gas, and that is why it is known as duplet atom. And the other noble gases atoms we know as octet. We say that their outermost shell contains 8 electrons, and that is why they are stable. That is why they are less reactive. They don't react. Okay, that is the reason we compare with the 8 electrons. Okay, so valence electrons are the electrons which are present in the outermost shell of an atom. So as we can have the overview as we go through further. So hydrogen, helium, lithium symbol is Li. So lithium's atomic number is 3. If we talk about configuration of lithium, so how we can write the configuration? Electronic configuration, EC, short form for electronic configuration. And what is electronic configuration? I have told you yesterday that electronic configuration is the arrangement of electrons, how they are arranged in the different shells of an atom. So electronic configuration of lithium will be 2 for K and 1 for 1 for L. Okay, so 2 and 1. This is the electron configuration. So as we see, if we make this for lithium, so this is L shell and I'll make one electron over here. Give up. Okay, so like this. So K having 2 electrons and 1 in, because only 3 electrons are there. So 1 in the L shell. Now, if we talk about the valency, how many valence electrons? So for these elements who are having valency or who are having the valence electron like 1, 2, 3. So those elements who are having the valence electron 1, 2 and 3, we say that it is equal to the valency of that atom. One means if somebody is showing, if some means hydrogen is showing 1 as a valence electron, so the valency will also be 1. So that is equals to, so valency of an element having valence electron 1, 2 or 3 is equal to the valence electron. Means the valency of these elements having 1, 2 or 3 like valence electron, their valency will be equal to the valence electrons. Means let's say if hydrogen is having one valence electron, so the valency will be also 1. If we will not talk about helium, because helium is so if it's having 2, so 2 minus 2, so the valency will be 0. Okay, that is the thing. So for helium the valence is 0. If we talk about lithium, the valency will be 3. Okay, so that is the form how we can show that the valency of the elements having 1, 2 or 3 valence electron, their valency is equal to the number of valence electron present in the outermost shell. Okay, so the number of valence electron present in the outermost shell is equals to the valency of that atom. So the number of valence electron is equals to the valency of that atom. Means if I am talking about lithium, so lithium, the outermost shell contains 1 electron. Okay, the outermost shell contains 1 electron, so the valency of lithium will be 1. Okay, so the valency of lithium will be 1 because only 1 unpaired electron is there. So for pairing that one unpaired electrons, the lithium needs 1. Okay, so that we can say, or it's easy to lose 1 electron for lithium. It's easy for lithium to lose 1 electron rather than taking 8 electrons from any other elements, because if he takes if he takes 7 electrons from any other element, the nucleus contains only 3 protons. What we say that the number of protons is equals to number of electrons. तो अगर मान लीजिए लिथियम जो है तो 7 इलेक्ट्रॉन्स उसके ऑक्टेट को कंप्लीट करने के लिए उसको कितने चाहिए 7 इलेक्ट्रॉन्स चाहिए. ठीक है, तो 7 इलेक्ट्रॉन्स अगर वो ले लेता है 7 इलेक्ट्रॉन्स, तो यहाँ पर क्या होगा, यहाँ पर प्रोटॉन्स तो बढ़ेंगे नहीं. तो इट इज नॉट पॉसिबल फॉर दीस प्रोटॉन्स, ये पॉजिटिव चार्ज के लिए पॉसिबल नहीं होगा कि इतना सारा नेगेटिव चार्ज होगा, दैट सम ऑफ नेगेटिव चार्ज को बैलेंस कर सके. That is why it is more easy for lithium to lose 1 electron. So calculating, how we can calculate? We can calculate in this sense that agar if in case the valency of an element having valence electron 1, 2 or 3 is equal to the valency of electrons. So the number of valence electron or the number of valency. Okay, जैसे helium के लिए it's having 1 valency. So the number of valency will be, the valency of lithium will also be 1. Okay, so in the same manner you can calculate the valency for the elements having 1, 2 or 3 valence electron in the outermost shell. Okay, we go further, hydrogen, helium, lithium, then we go to beryllium. Beryllium having 4 electrons. What will be the EC? electronic configuration for beryllium, that will be 2 and 2. So the outermost shell of beryllium contains 2 electrons. So if I make this beryllium, so 2 and then 2. So what will be the valency for beryllium? Anybody wants to tell me what will be the? Yes, that will be 2. As we said that जितने number of valence electron को show कर रहा है उसके outermost shell में कोई भी element हमको we should know the EC, electronic configuration of that atom. Okay, if we know that, we can calculate the valency for 1, 2 and 3 valence electron. Agar if in case element having 1, 2 or 3 valence electron in the outermost shell, then that valence electrons are equal to the valency. So for beryllium also 2 will be the valency. क्योंकि उसके outermost shell में कितने electrons हैं? 2 हैं. So that will be more easy for beryllium to lose 2 electrons rather than to take 6 electrons to complete the octet. Now we come to hydrogen, helium, lithium, beryllium, boron, B. Yes. So boron 5. Okay. So 5 is the atomic number for boron. Please tell me the electronic configuration EC for boron. That will be 2 and 3. Okay, so 2 and 3. Now, what is the 2 and 3? 2 in K and 3 in L shell. The outermost shell for boron will be L, and in the outermost shell, how many electrons are there? 1, 2 and 3 electrons. So for boron, it's easy to lose 3 electrons rather than gaining. How much electrons he wants then to complete? Please tell me how much electrons he will complete the octet? 5 electrons. Yes. So 5 electrons boron need, but it's not possible for boron's nucleus to capture 5 electrons to hold these extra 5 electrons, because अगर boron की बात करें, if you talk about boron, the nucleus of boron contains only 5 protons. So extra 5 electrons means 10 electrons and 5 protons. That will be not possible. So the charge will is more negativity and less positivity. So that is the reason he tried to lose these 3 electrons rather than gaining 5 electrons. Okay, so that is why boron is having the valency of. So how we are calculating valency? For 1, 2 and 3, the elements having 1, 2 and 3 valence electrons. How we are calculating that the number of valence electron is equals to the valency of that element. So for lithium the valency is 1, for beryllium that is 2, and for boron that is 3. So is it okay? So for lithium that is 1, for beryllium that is 2, and for boron that is 5. So just try to learn the electronic configuration, the AC of an element. With as we are in 9th class, we are up to 20 only. We see the elements up to 18 and 20 only. So for that, you should know the AC, the electron configuration, and through that we can calculate for right now we are calculating for 1, 2, and 3 the valence electron present. So if an element is like lithium having 1 valence electron, the valence will be 1. Beryllium having 2 valence electron in the outermost shell, the valence will be 2. Boron is having 3 valence electron in the outermost shell, and the valence will be 3. Okay, so in this case, so the valence electrons are the electrons. So the valence electrons are the electrons which are present in the outermost shell of an atom or an element, you can say. And the valency is the number of the combining capacity of that atom, the combining capacity of that element, the atom. So valency. So as lithium having 1 valence electron, the valence of combining capacity, what will be the combining capacity? The 1 will be the combining capacity of lithium. Okay, the valency of lithium will be 1. So combining capacity of lithium will be 1. But if we define valency, what is valency? The combining capacity of an atom. That is valency of lithium. The valency of lithium is 1. So lithium can give 1 or combine with 1 more electron with other element and form a compound. Okay. So that is the thing. Lithium has one valence electron. Beryllium, if we talk, having two valence electron. So beryllium, the combining capacity of beryllium will be 2. He can share 2 electrons with other element to form a compound. Okay. Now talking about boron. So boron having 3 valence electrons in the outermost shell. The valency of boron will be 3. So 3 electrons boron can share with the other element to form a compound. Okay. So this is the valency and this is the valence electron. Now we go to further more. After boron, so hydrogen, helium, lithium, beryllium, boron. After boron comes carbon. Okay, so I'll just rub this. Hydrogen, helium, lithium, beryllium, boron, then carbon. What is the atomic number of carbon? Hydrogen, helium. You can count or you can just learn and remember. Hydrogen, helium, lithium, beryllium, boron, carbon. So carbon comes on 6. Write the EC for carbon. EC means electronic configuration. So electron configuration of carbon will be 2. And how many electrons left? So 6 minus 2. That will be 4. Okay. Now comes a difference in the calculation of valency. Okay. Now after 3, after 3 means how up to 3, the valence electrons up to 3, how we have calculated? So the elements having valency of 4, 5, 6 and 7. Okay, the elements having valency of 4, 5, 6 and 7, the valency can be calculated as is equal to the number of electrons to be added, so that the valency shell has 8 electrons. So the number of valence electrons to be added, how many we have to add to complete the octet? For the valence electrons from 4. So the valence electrons from, if I write over here. Okay. So the valence electron 4, 5, 6 and 7. For 4, 5, 6 and 7, the valence electrons, if an element contains valence electron 4, 5, 6 or 7. For calculating valency, what we have to do? The number of electrons to be added to complete the octet. The number of electrons to be added to complete the octet. So for talking about carbon is having atomic number 6. The EC of carbon is 2 and 4. So how many? So the valence electron for carbon, the valence electron for carbon is 4. 4. This is the structure for carbon. Okay. 1, 2, 3, 4, 5, 6. 6 electrons in carbon. So how many electrons carbon need to complete the octet? Okay, how many electrons carbon need? Carbon need 4 electrons to complete the octet. Okay, so how we have calculated this? So we know valence electrons present in the outermost shell, that is 4, and how many we need to complete the octet, that is 4. Okay, so as we can say that valency equals to, we can have a formula for electrons. The valence electrons having 4, 5, 6 or 7 number of valence electrons. So valency equals to 8 minus number of valence electron. Okay, so the number of valence electrons. So valency हम कैसे calculate कर सकते हैं? For the elements having 4, 5, 6 and 7 valency. The number of, so 8 minus number of valence electron. Okay, so if I minus 4, so 8 minus 4. Okay, so 8 minus 4. So what will be the valency for carbon? Equals to 4. So 4 will be the valency for carbon. Okay, so carbon needs 4 more electrons to complete the octet. But as we know that it's hard for an element to acquire more 4 electrons, because in the nucleus of carbon, how many protons are there? Only 6 protons are there, because we know that for a ground an atom which is neutral. So the number of proton is equals to number of electron. Okay, electron और proton की संख्या बराबर होती है. अगर हम what we do, we add 4 electrons, more 4 electrons, so the balances will go. So carbon, what carbon do? Carbon shares the electrons. Shares the electrons, 4 electrons with other 4. Sharing happens and the covalent bonding happens in carbon. So carbon, after carbon, so hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen. So nitrogen is having 7. So the EC of nitrogen will be equals to 2, 5. Okay, so 2, 5. So 8 minus 5. According to the formula for calculating the valency of 4, 5, 6 and 7 valence electron, the formula is 8 minus number of valence electron. 8 minus number of valence electron. Okay, so if we talk about nitrogen, so 8 minus 5 will be, what will be number 8 minus 5? Tell me, that will be 3. 8 minus 5, that will be 3. So what is the valency of nitrogen? 3. Nitrogen need, so this was for carbon, I will just add one more electron. So 1, 2, 3, 4, 5, 6, 7. Now 7. How many electron carbon needs to complete the octet? That is 3 electrons carbon need to complete the octet. So that is the valency for nitrogen. Nitrogen. So 3 electrons nitrogen need to complete the octet. So the valency for nitrogen. Okay. So the valency for carbon, what was the valency for? The valency for nitrogen will be 3. Okay. So here I am writing the valency. Okay. So for nitrogen, the valency, the symbol of nitrogen is N, the symbol of carbon is C, the symbol of boron is B, the symbol of beryllium is Be, lithium Li, hydrogen, helium He, and hydrogen H. Okay, so this we have done with the IUPAC nomenclature, that the first letter should be capital, what we have seen in the previous chapter. So after this we comes to another element. The next one is hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, and oxygen. O for oxygen. So oxygen, how many? What is the atomic number for oxygen? That is 8. The atomic number for oxygen is 8. What is the EC of oxygen? That is 2, 6. Okay, so 2 and 6. So how many electrons, how many valence electrons oxygen have in the outermost shell? Electron configuration, look towards the electron configuration and you can tell that what is the valency, what is the valence electron, how many numbers of valence electron are present in the outermost shell of oxygen. Oxygen का outermost shell कौन सा है? The outermost shell of oxygen will be L. Okay, L is the outermost shell and oxygen have 6 valence electron. So just make one more. So 1, 2, 3, 4, 5, 6, 7, 8. Total 8. Okay, so total 8 and the outermost shell. The L shell contains 1, 2, 3, 4, 5, 6. 6 electrons in the outermost shell. So what will be the valency of oxygen? As we know that the valency for the valence electron present in the outermost shell of 4, 5, 6 and 7 is the valency equals to 8 minus number of valence electron. So oxygen is containing 6 valence electron. So 8 minus 6, that will be 2. So 2 is the valency for oxygen. Okay, 2 will be the valency for oxygen. So oxygen need 2 electrons to complete the octet. So for oxygen, it's easy to take 2 electrons. Okay, rather than losing 6 electrons. Okay, it's hard to lose 6 electrons for oxygen. So what oxygen do? Oxygen takes 2 electrons because so the oxygen having electronegativity. Nitrogen also do the same thing. Nitrogen also takes 3 electrons rather than losing 5 electrons. Okay, and for oxygen also, for losing 6 electrons, it's more hard now. So it's taking 2 electrons is more easy. That's why oxygen, what oxygen do? Oxygen takes 2 electrons and complete the octet. So for oxygen, for completing the octet, only 2 electrons needs. So the valency for oxygen will be 2. And we have calculated with the formula valency equals to 8 minus number of valence electrons. Okay, so this is the manner how we can calculate the valency. Now we come to hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen के बाद में आएगा. What will come after oxygen? Oxygen के बाद में आएगा. Yes, fluorine. Okay, so fluorine will come, and the atomic number for fluorine will be 9. So easily please calculate the EC will be 2 and 7. So 8 minus 7, that will be 1. So 1 will be the valency for fluorine. So fluorine needs only 1 electron to complete the octet. Means the electronegativity. What is the electronegativity? What is electronegativity? This thing you will read in further classes. But what is electronegativity? Electronegativity is the part take the electron, the urge to take the electron, the urge by an element to capture an electron. So fluorine is highly electronegative because it just wants 1 electron, only 1 electron to complete the octet and to become a noble gas element. Okay, so to become noble gas, or you can say to become stable. So fluorine just needs 1 electron. So fluorine's electronegativity is very high because एक ही इलेक्ट्रॉन चाहिए. एक इलेक्ट्रॉन को कहीं से भी कैप्चर कर सकते हो. It's easy for him to grab electron. Okay, so fluorine is easy. The electronegativity is high for fluorine. Okay, so 1 is the valency of fluorine. We just need 1 electron to complete the octet. अब हम इसको ड्रॉ करें फ्लोरीन के स्ट्रक्चर को. तो this is for fluorine. If I count the total number of electrons in the shells of fluorine, that is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and in the outermost shell that are 1, 2, 3, 4, 5, 6, 7. So 7 valence electrons are present in the outermost shell of fluorine. And what we know, how do we calculate the valency? Valency equals to 8 minus number of valence electrons. So 8 minus number of valence electron are 7. 8 minus 7 is 1. So the valency for fluorine will be 1. Okay. So that is for fluorine. Now we have come up to 9. So hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and it comes to neon. Okay. So neon is the what is neon? And E for neon. Okay. It's I will rub this thing. So from hydrogen we'll just keep the labelings of these elements to go through with the names. So neon is we know that hydrogen is 1, 2, 3, 4, 5, now 6, 7, 8, 9, and then neon will be 10. So we see the EC for neon is 2 and 8. 2 and 8. Okay, so 8 gives the octet. And as we have seen for noble gases that they are very, very less reactive because they don't have any unpaired electron in the outermost shell. Okay, so we go how? So we go through with the formula which we have taken. So valence equals to 8 minus number of valence electron. For neon, the number of valence electron is 8. Okay, so 8 is the formula for valency. Okay, so 8 minus 8, that will be 0. Okay, so the number of valence electron for neon will be 0. Okay, the number of valence electron for neon will be 0. So the valency of neon will be 0. Okay. And as for the neon structure, what we can do, just add one more electron. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 atomic number or 10 number of electrons, and the outermost shell is containing 1, 2, 3, 4, 5, 6, 7, 8 electrons. Okay, so that is why neon is having 0 valency, because neon don't have any valence electron present in the outermost shell. Valence means unpaired electron. What is valence electron? Unpaired electrons, because electrons always remain in pairing. Okay, two sets of electrons always present. Okay, so a single electron, so that is valence electron. If in pair, so that is complete. You don't need another more electron. Okay, so that is why. So that is the thing. So the valency for neon will be 0. Okay, now we'll move further. Yes, so as we move further from neon, okay, from neon to sodium. So sodium. So hydrogen, helium, lithium, barium, boron, carbon, nitrogen, oxygen, fluorine, neon, and then sodium. That is Na. Okay, so that is sodium. Here after neon, that is sodium. So sodium's atomic number is 11, and you all know that. So यहाँ से फिर से दो चीजें, as you have changed the rule for finding the valency from carbon, from the 6th element. So from carbon to 10, what we have done, 8 minus number of valence electron, and before that from 1 to 5, what we have done, जितना valency है, valence electron जितना है, जितना number of valence electron outermost shell है, उस वो equals to है valency है ना? So number of valence electron जो कि present है outermost shell, that is equals to the valency of that element. So for hydrogen the valency was 1, for helium that is 0, because 2 है, so there is no. So lithium, that was 1, 2 and 1. So 1 was for lithium, barium 2 and 2. So 2 was the. So in the same manner, sodium in our case, from 11 to 20, it will be same. So EC. So electron configuration if I write about for sodium, that is 2, 8 and 1. Why I have given 1 in the, that is K, L, M. So the M will contains 1 valence electron. We know with the how we have written the electronic configuration for the elements with the distribution law. The formula was 2n square. मैं फिर से बताता हूँ आप लोगों को, पिछली क्लास में the last class we have studied this, the distribution of electrons in the shells. So the formula for the first rule was 2n square formula. So for K, 2, so K is the first shell, and denotes the number of shell, and equals to number of shell. Okay, so for K, the number of K is the first shell, 2 into 1 square, that will be 2. Okay, for K means K will contain 2 electrons. K will contain 2 electrons. In the same manner for L will contain 8 electrons. So यहाँ पर क्या हो गया, L हमारा L full हो गया है. अब L is not having the capacity to take more electrons. So the electrons will move further to M. The electrons will move further to M. Okay. So now M में सबसे पहले नाइट्रोजन सोडियम की बात करेंगे, है ना? So सोडियम की बात अगर हम करेंगे, so that will be sodium containing 11 electrons. 11 electrons. The electron configuration is 2, 8 and 1. So 1 is the valency of sodium. जैसे हमने कहा कि from 11 to 20, what will be the rule then? Finding the valency. Now this will not be the rule. From 11 to 20. The rule will again change. Okay. Now the rule for from 11 to 20, or we can see the number electrons, the valence electron from 1 to इलेक्ट्रॉन्स हैं उतना ही वैलेंसी होगा. So the valency will be equals to valence electron. Okay, so the valency will be equals to valence electron. So for sodium the valency will be 1 because he needs 1 electrons, or we can say that he will lose 1 electron. It's more easy for sodium to lose 1 electron rather than how many electrons the M shell needs. What is the capacity of M? M का capacity क्या होगा? So M is the third. 2 into 3 का square, that is 2 into 9, that is 18. So 18 is not possible for sodium to have 17 electrons. Okay, to take 17 electrons rather than losing 1 electron. So for here sodium के लिए हम लोग क्या बोल सकते हैं कि वो एक इलेक्ट्रॉन को लूज कर रहे हैं. तो सोडियम विल फॉर्म Na पॉजिटिव. ओके, सोडियम विल फॉर्म Na पॉजिटिव. ओके, सो सोडियम will lose 1 electron or the valence will be 1. Sodium, hydrogen, helium, lithium, beryllium. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, chlorine, neon, sodium, then magnesium. Magnesium having 12 atomic number 12. Electronic DC is 282. So हमने क्या कहा, valence is equal to valence electrons, number of valence electrons. So the valence will be 2 for magnesium. So structure हम बनाए हैं. If we draw the structure for sodium and magnesium, sodium, this is the structure. Sodium just adding 1 more electron. For magnesium, this is the structure for magnesium. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Magnesium 12, electronic configuration 2, 8, 2, valence is 2. Okay, so for magnesium the valence is 2, and in the same manner just find out the valency, just find out the electronic configuration for different up to 20, and that how we can find out the valency. The valency is equals to number of valence electron. तो जितना valence electron outer most shell में उनके बचे हुए हैं, that is equals to the valency. They will easily lose 2 electrons rather than accepting more electrons.